Hello and welcome to today's video, where we are discussing addition and subtraction with significant figures. For addition and subtraction, your answer is only as precise as the least precise value in the series. So let's do a quick talk about precision in numbers with an example with pi. So here you'll see varying degrees of precision with pi, ranging from 3 to 3.14159. You'll see that as you move to the right, the number adds more numbers after the decimal place, okay? And these numbers over here on the right are more precise than the numbers with fewer decimal places. So essentially, the more digits after the decimal point, the more precise your number will be. So let's do an example to show this. So let's say we take our more precise value of 3.14159 and add it to 3, our less precise value in this number. So if we do the math, we'll get 6.14159. Okay, but we just said that the definition for addition and subtraction with sig figs is your answer can only be as precise as the least precise value in the series, which we know is 3 because of the graph that we already talked about, right? So if we say that 3.14159 has 5 numbers that come after the decimal point, and 3 has 0 numbers that come after the decimal point, we know that our answer will only be able to have 0 numbers after the decimal point, because your answer can only be as precise as the least precise value, which we said has 0 decimal places. So to illustrate this, what we're going to do is draw a line down from where they differ in their precision, okay? And then we're just going to see if the number that comes right after that line can round our number that we are keeping to anything. And in this case, 1 does not round, so here our answer would just be 6 with the sig fig rules. Let's do another example with subtraction. With this example, you'll see that the first number is written in scientific notation. So with anything with addition and subtraction and sig figs, we are always going to write out scientific notation in the standard form, okay? So that we can compare apples to apples and we don't make any mistakes in not noticing that the scientific notation exponents are different. So here I have written out the numbers in standard form and stacked them. So the ones line up with the ones and the tenths line up with the tenths, etc. So if we do the math here, we will get that 4100 minus 0.05283 is the following. It is 4099.94717. Okay, so let's do what we just did. So the first number has 1 number after the decimal point, and the second number has 1, 2, 3, 4, 5 again, so 5 numbers after the decimal point. We know that your answer has to match up with the one that has the least number of decimal places, okay? So in this case, that would be 1. So again, we're going to draw the line extending down from where they differ and see if the number that comes after that line of what we are not going to be including for precision can round it to anything. And in this case, that does not round, so our answer will be 4099.9. And that is our answer for this problem with sig figs. Okay, so this next example has addition and subtraction. Again, we'll see that one of the numbers is written in scientific notation. And even if all of them were written in scientific notation, we are going to always start by writing out all of the numbers in standard form and stacking them, okay? So we are going to quickly do the math. I plugged it into the calculator. It is 4.05777. And then we are going to draw our arrow where they differ in the precision. So the 4.013 will be our limiting one. It is the least precise. And we see if this 7 can round that 7 to anything. And it will, because 7 rounds. So 4.058 is our answer here. Okay. When I was making this video, I was seeing that a lot of people were confused with whole numbers. So whole number addition and subtraction relating to sig fig rules. So we're going to do the next few examples relating to whole numbers. So we are going to start by doing the math, and then I will explain the rules. So 104 plus 50 would be 154. Okay, so with whole numbers, you basically have to see if any of them have trailing zeros, okay? Like the 50 here. So what makes this important is we don't know if the 50 was rounded from 45 or 54, okay? You'll notice that if the number was even as low as 45, 45 rounds to 50, and as high as 54, 54 rounds down to 50. So this 50, because that 0 is uncertain, this 50 could have been anywhere from 45 to 54. So that makes that number in the ones place uncertain, okay? So the only number that we're certain of in the 50 is the tens place. And because of that, our answer will be uncertain in the ones place because 50, when there's that 0 there, that makes it uncertain. So what we do is basically the same thing we did with the first examples, is we're saying that that ones place is uncertain. So we're seeing if that can round to anything, and it does not. So here our answer is 150 because the ones place is uncertain. Okay, let's do another example. So now you'll see that both the 100 and the 50 both have zeros. So first we're gonna do the math and then we're gonna start highlighting things. So again, we're just gonna drop down anywhere where there's a 0 with that highlight, okay? And we're dropping down until there's no more zeros on either of the numbers. So in this case, you'll notice that both of them have zeros. Don't let that trip you up. So if it was an example just with the 100 and like 55, it still would be both of these. Or if it was like the 50, like this example here, it would just be that ones place. Okay. So both of these are uncertain because those zeros aren't significant. So we're not sure what those numbers actually should be. They might have been rounded, we don't know. So we'll do the same thing we did before, is we'll take the number closest to what we're gonna keep and we'll see if we can round. And here we can, and your answer will be 200 then for this problem because of the uncertainty in those zeros and the precision. So let's do another example, 250 minus 5. Again, let's do the math first. 250 minus 5 would be 245. And again, we just take our highlighter and drop it down until you hit the first non-zero number. And in this case, it comes immediately after that first one. And we're gonna see if the 5 can round to anything, and it can. So here our answer is 250. Okay, let's do the next one. So we'll take 12,000 plus 5,300. And again, we're just gonna do the math before we talk about any of the precision. And that would be 17,300. Okay, so again, we're just gonna drop down when there's zeros there. Okay, and now there's no more zeros left. So we are going to take this and round, and that does not round. So our answer is this. Okay, last example with the whole numbers. So again, we're just gonna do the math pretty quickly, 670. And you are going to take your highlighter. You're gonna take the highlighter and go down until you get all of the zeros taken away, which is right there. And then you will see if you can round, and you can. And your answer is 700. Really quickly, I want to go back to this specific example and say that this example, this number could be anything from 150 to 249, okay? It's not really 200. You're not really saying that the number is 200. This number is really encompassing, saying it really could be anything from 150 to 249 because of rounding, right? In any of that range, the numbers would round down to 200. So that's why if you're confused, if you're like, but 100 plus 50 is not 200, these are the sig fig rules, and it's essentially saying that we're saying it's 200 because of the precision, but technically, if you think about the logic behind it, the rounding saying it's anything between 150 and 249. And these examples are really indicative of why scientists measure to multiple decimal places, because you really don't want this degree of variability, right? This is almost 100 100 numbers. You really don't want that. So that's why you want to add more significant figures and more decimal places to make your number more precise and a smaller margin of error in your measurement, which is what we talked about originally with precision. Thank you so much for watching. Please comment below any questions you have and let me know what topics you would like covered next.